Today we're going to be talking about measuring segments. And the first thing I want to talk about is the warm-up that you guys just worked. So looking at numbers 1 and 2, you had to find the absolute value of these expressions. So number 1, you had to find the absolute value of 4 minus 7. Well, when we take the absolute value of something, we take the positive answer of it. So although 4 minus 7 is negative 3, the absolute value of negative 3 is just 3. Okay? And then we had to do the absolute value of 4.3 minus 1.2. Okay? So the absolute value of that, well, 4.3 minus 1.2 is 3.1. So the absolute value of that is just 3.1. Okay? Now let's look at the fish problem. Okay, so while fishing on Caddo Lake, you catch the fish above. By law, you must release this fish if it is between 14 and 18 inches long. You need to measure your fish, but the front of the ruler on the boat is worn away. Can you keep your fish? Explain how you found your answer. Okay, so what you would do is you would take your fish and you would use the part of the ruler that you do have. So for example, if I take this ruler right here, and I can see from mouth, fin is from 17 to 30, I can do, let me scroll down a little bit. I could do, okay, well, what is the difference in those two numbers? So I could say the absolute value of 17 minus 30, well, the absolute value of 17 minus 30 is 13. So it's 13 inches. So can you keep your fish? Yes, you can. You can keep your fish. Okay, let's move on to today's notes. Okay, so, oops, sorry. All right, so what is a position of a point on our number line? That is called a coordinate. Coordinate. Okay, so in the ruler postulate, it says a lot of things. It starts saying something like every point on a line can be paired and blah, 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 blah. It says a lot of things, but what it really means is that the distance between any 2 points is the absolute value of the difference of the coordinates. So that is the ruler postulate. The distance between any 2 points is the absolute value of the difference of the coordinates. Okay, so let's look at this example. It says, what is AC? So because there's no line over it, where I'm asking what is the distance from point A to point C. Well, we can see that point A is at -2 and that point C is at 5. So all you have to do is write that AC, oops, I'll stop again, that AC is equal to the absolute value of -2 minus 5. Okay, because the ruler postulate says the distance between any 2 points is the absolute value of the difference of the coordinates. So the coordinates of point A is -2. The coordinate of point C is 5. So the difference means to subtract, so -2 minus 5. Okay, so we know that -2 minus 5, let me scroll down, is going to give you -7. But the absolute value of -7 is 7. So the distance from A to C is 7 units. Okay, y'all pause the video and y'all work number 2. Okay, so you're asking what is the distance between point A and point B? Okay, so we know that the ruler postulate tells us that it's the difference of the coordinates, absolute value of the difference of the coordinates. So point A is at -2, and I'm going to subtract point B, which is at 1. Okay, so we know that -2 minus 1 is -3, and the absolute value of -3 is just 3. So the distance from A to C is 3 units. Okay, so let's move on to the segment addition postulate. Okay, so segment addition sounds like we're going to be adding segments together. So let's look and see what it says. Okay, it says if 3 points A, B, and C are collinear and B is between A and C, so let's look and see what that actually looks like. So here's what it's saying do. You have, okay, so you have a line, because it says they are collinear, so here's your line. Okay, and you have points A, B, and C which are collinear, but B is between points A and C. All right, so, whoops, sorry, you don't need a star there, you need a point. All right, so point A can be here, point C can be here, and point B is between them. Okay, so A, B, and C are collinear, meaning they lie on the same line. Okay, so we know that this segment right here, AB, plus this segment right here, BC, oops, is going to be equal to the length of the whole thing. Okay, so this segment plus this segment equals the whole segment. So one thing that we can say is the sum of the parts is equal to the whole. Okay, and this is actually pretty important. Okay, so the sum of the parts is equal to the whole. So let's look at an example. Okay, so looking at this first one right here, we have if EG is equal to 59, what are EF and FG? Okay, well, EG is the length of this whole thing, right? And then EF is this part, which is 8x minus 14, and FG is this part, which is 4x plus 1. Okay, so we want to know if this whole thing is 59. What are EF, oops, pen doesn't want to work for me tonight, EF and FG. Okay, so here's what we're going to do. We're going to make an equation. All we have to do is set up, let me get my pen working right here though, hold on one second. Okay, so we know that the sum of the parts is equal to the whole. So we know that EF plus FG, that's a G, I promise, equals EG. Okay, so let's fill in. We know that EF is 8x minus 14. We know that FG is 4x plus 1. And we know that EG is 59. Okay, so now we have an equation. And the reason this is important is because if we want to know what EF is, we have to know what X is. If we want to know what FG is, we have to know what X is. And in order to find a variable, you have to set up an equation and solve it. So let's go ahead and combine our like terms over here on the left side. We have 8x plus 4x, which is 12x. And we have negative 14 plus 1, which is negative 13. And that's equal to 59. Okay, so to solve this, we need to get everything away from the x, which is on the left side. So this is minus 13 right here. So I'm going to add 13 to both sides. And when I do, I'm going to have 12x equals 72. Okay, now I need to get rid of the 12 because I want x by itself. So I'm going to divide both sides by 12. And when I do that, I get that x equals 6. Okay, but I'm not done because the question asks what are EF and FG. So I have to actually write what they are. So let's look at this. There's a couple different ways we could do this. All right, let's go ahead and find EF. EF is 8x minus 14. Well, I know what x is now. So all I have to do is plug in 6. So we know that 8 times 6 is 48. And oops, I'm drawing lines again. And we know that 48 minus 14 will give you 34. So EF is 34. Okay, now we could go ahead and plug X in for FG, or we could just subtract 34 from the total, which is 59. You're going to get the same answer no matter which way you do it. I'll just plug it in real quick. All right, so over here, let's see if I can place it right. All right, so we know that, making lines, FG equals 4x plus 1. So you have 4 times 6, which that's what x was, plus 1. So 4 times 6 is 24. So you have 24 plus 1. So we know that FG is 25. Okay, so y'all pause the video and y'all take a shot at number 4 here. And then check back and check your answer. Okay, so here's the answer to number 4. Take a moment, pause the video, and check your work with this. You do it exactly the same way as you do number 3. Okay, so congruent segments are segments with the same length. And the symbol for congruence is just the equal sign with a squiggle on top. Whoops, but not a line going through your page, not like that. Okay, so equal sign with a squiggle. And a thing to remember, lengths are equal. So the distance from A to B is equal to the distance from C to D. Lengths are equal. This is really important. And I want to make sure that y'all retain this information. Okay, so lengths are equal. So the distance from point A to point B is equal to the distance from point C to point D. Okay, now segments are congruent. Remember this too. Okay, so segment AB is congruent to segment CD. That means that these two segments have the same length. If AB is 4 inches, that means C is 4 inches. Okay, they have the same length. Okay, lengths are equal, segments are congruent. Segments are the same, they're congruent. This is what this means. Okay, all right, let's look at an example. Okay, so this question says, are AC and BD congruent? So is the distance from point A to point C the same as the distance from point B to point D? And that's what we have to figure out. So if the distances are equal, that means the segments are congruent. Let me say that again. This is important. If the distances are equal, then the segments are congruent. Okay? So the first thing we need to do is we need to find the distance from A to C. Okay, so I want y'all to pause the video, take a moment, we've already done this in the previous example, and find the distance from A to C. Okay, so I've gone ahead and set this up for you. Let's look at this. The distance from A to C, remember, it's just the difference in value of their, the absolute value of the difference of their coordinates. So point A is at -2 and C is at 5. Okay, so I'm going to solve this right here. So we know that -2 minus 5 is -7. And the absolute value of that is 7. So we know that AC, the distance from A to C, is 7. Let's look at BD here. B is at 0.3, and D is at 10. So we have 3 minus 10, which would be -7. So again, the absolute value of -7 is 7. So BD is equal to 7. Okay, so we know from this, let me get a different color here to write with. All right, we now know that the distance from AC to BD is equal. A to C and to B to D is the same. Distances are equal. Because those are equal, we now know that AC, segment AC, is congruent to segment BD. Okay, which is what the question was asking. Are they congruent? So yes, they are. I want to make an important statement right here. Okay, this right here, whoa, don't want to make a statement like that. I want to highlight it. All right, this statement right here, that is called a congruence statement. I'm going to write that over here. It is a congruence statement. One segment is congruent to the other. That is a congruence statement. Okay? All right, let's look down at some more of these definitions here. Okay, midpoint is a point that divides or bisects the segment into two congruent segments. Okay, midpoint is a segment that divides or bisects the segment into two congruent segments. And this midpoint, this point is equidistant from the endpoints of the segment. Okay, so what does equidistant mean? Okay, let's draw one. My segment. Here's my segment over here. Okay, let me label it. So we'll say that this is, let me be real original here. This is A, and this is M. And let's say that the midpoint is point L. I know that doesn't look exactly right, but we're going to pretend. Okay, I'll move it over some. There we go. Okay, so if the distance If L is the midpoint of segment AM right here, that means the distance from A to L is the same as the distance from L to M. And those are just congruence marks that I just did. Those two segments right here now, AL and LM, have matching congruent marks, meaning they're the same. That means that point L right here is equidistant to point A as it is to point M. So it's the same distance. So equidistant means it's the same distance. Okay, so I'm just going to make a little same distance. Okay. All right, let's talk about a segment bisector. Okay, so a segment bisector is a segment, ray, line, point, or plane that intersects a segment at its midpoint. So looking at this drawing that I've got right here, okay, so I've got segment AC drawn, okay, so looking at this, B here is the midpoint of segment AC, okay, and I know that because I have these matching congruent marks right here, meaning that AB and BC are the same. So B is equidistant to point A and point C. But there's a line going through point B here, line R is. And because line R is going through the midpoint, line R is a segment bisector of segment AC. It's bisecting the segment, it's cutting it in half through its midpoint. Okay, let's look at some examples. Okay, so looking at this, this says that Q is the midpoint of PR. What are PQ, QR, and PR? Okay, so let's talk about what we know here. We know that if Q is the midpoint, that means that we have two congruent segments here. We know that PQ and QR are the same because Q is equidistant to both P and R. Okay, so we need to know what these segments are. If I knew what X was, I would know what PQ is. If I knew what X was, I would know what QR is. If I knew what both of these segments were, I know what the whole thing is because I could just add these two numbers together, right? Okay, so how are we going to do that? I want you to pause the video, take a second, and figure out how to set up that equation, and then check back. Okay, so the true thing that we know is that PQ is equal to QR, and we can set at 6x minus 7 equals 5x plus 1. So I'm just going to fill in here with 6x minus 7 equals 5x plus 1. Okay, I want to solve this for x. They're on two separate sides of the equation here. So to do that, I'm going to move 5x to the left side here. So I'm going to subtract 5x from both sides. So 6x minus 5x is x. So I have x minus 7 equals, now I don't have 5x over here anymore. So this is just equals 1. Okay, so to solve for x, I now need to move negative 7. So I'm going to do the opposite. I'll add it to both sides. So I'm going to add 7 to both sides. So you get x equals 8. And this is super helpful because now I can just plug x, 8, in for x here and here. So I'm going to go ahead and do that. Y'all pause the video and y'all go ahead and finish that for me. Okay, so we know that PQ is equal to 6x minus 7. So all I had to do was plug in 8 in place of x because we already found it over here. And 6 times 8 is 48, and 48 minus 7 is 41. So I know that PQ is 41. Okay, now let's talk about QR. Y'all go ahead and find that for me. Okay, so we knew that QR, it was 5x plus 1. All I did was substitute in 8 for x here. 5 times 8 is 40. 40 plus 1 is 41. So QR is 41 and PQ is 41. Did I have to do that? No. Can you tell me why? Because these are two congruent segments. If this is 41, so is this one. Okay? But if you want to check your math, that might be a good thing to do, is go ahead and find it too. But we know that these two are congruent, so you don't have to go find it. Okay, so I want to know the length of the whole thing. So I already know PQ and I know QR. They were the same, so they're both 41, right? All right, so to find the length of the whole thing, you just add PQ plus QR. So 41 plus 41. Okay, so you can say 41 plus 41, or you can just say 41 times 2. So PR is 82. Okay, so those are our three answers that we were asked to find. Okay, I want you to take a moment and read the things on the sticky note over here. Pause the video and answer each one of them. Okay, so which point on the segment is a segment bisector? Well, Q is, because it's a point that intersects the segment at its midpoint. Okay, Q is the segment bisector. Okay, what symbol would you use to show the relationship between PQ and QR? Well, these are segments PQ and segment QR, so the relationship, remember, between segments, they are congruent if they're the same measure. All right, what is the relationship between PQ and PR? Well, PR, which was 82, and PQ, which is 41, well, PR is twice that of PQ. So PR is equal to 2 times PQ, which is what we did over here. Okay, so now I want you to work the closing task, and I will check back in with you guys. Thanks so much. Bye-bye.